Let's start the class. Uh, Good afternoon, everybody. So today what I am basically going to discuss with you is something regarding the classification of rapid prototyping. The classification of rapid prototyping in theoretical aspects is something which is very vague, and you would not generally find the classification in books. But what you can understand after studying this course is that there are two forms of classifications that you can make. One classification is basically based on the type of raw material that you are using, definitely. And the second classification can be totally based upon the type of energy resource that you are using in order to create the binding mechanism between the layers of the material. So based on that, I have tried to create a classification, and I'll share that classification with you. So the first classification that I have over here is basically a classification which is based on raw materials, a classification which is based on raw materials. Now, when you talk of raw materials in additive manufacturing or rapid prototyping, there are three broad specifics of materials that are used. Now, there is a solid. Solid can be divided into three classifications, that is wire, where wire is used as an input material, foil, or powder. So these are the three broad areas, and these are the areas which are primarily being developed for additive manufacturing. The second classification is liquid. In liquid, generally what we have is a resin, and this resin is actually a photocurable resin, which when exposed to ultraviolet light or low intensity lasers, it creates photopolymerization, it generates photopolymerization, and hence the binding, the chemical actions take place, and then there is localized heating and melting and solidification, all that stuff goes about. The last one is gaseous. Now, this system is something which was actually not developed on a commercial scale, but yes, it was developed at a lab scale, and it was actually presented as a prototype. So this reactive gas based system actually works on a very simple principle, that when you bring out two gases who react with each other, those two gases will actually cause a chemical reaction, and that chemical reaction will actually evolve some amount of heat within the process, and that heat will be utilized for solidification process. So that is the basis of developing the gaseous system. Primarily what we focus is solid and liquid, definitely. So I'll just give a brief explanation or brief introduction regarding the mechanisms which are there. Now, first thing is wire. Now, wire is basically something like a thread which is going to pass through a nozzle. So this will be a nozzle mechanism. This will be nozzle. And here in the nozzle, there will be heaters. And the wire will pass through them. As it passes through heaters, what will happen? It will change its phase from solid, but not to liquid, in between solid and liquid. Do you know the name of the phase in between solid and liquid? What is the phase between solid and liquid?
Semi-solid.
That is not semi, it's not named as semi-solid, it is called as solidus. It is called as solidus. So the idea is to convert solid to solidus and then bring back solidus to solid state. Okay. So what happens under solidus state? Any idea? What happens under solidus state? There are certain properties that the material attains. One of those is fluidity. The second one is density changes. The density of the material changes. Then you have got something of a shape change also. The wire actually starts to get converted into beads. A bead which may be spherical in shape, or it may be something like a drop of water, something like this. So the shape is basically haphazard shape right now, but the shape is something like a spherical or a drop of water. So we call it as a bead shape. So that shape actually helps us to create the structure. So under in wire category, this is what happens. The solid wire is brought onto solidus by heating, with the help of heaters, and then as it comes out of the nozzle, it comes under atmospheric condition. As it deposits, it starts to go back from solidus to solid. So this is how the mechanism of wire works. Okay. Now let us come to the mechanism of sheets. Now under sheets, what basically happens is, here the action of laser or the mechanism of heat is actually completely different from the other systems. Under foil, what happens is that here is a laser system. This is your laser system. Generally, it is CO2 laser of around 10 to 40 watts. So we have a CO2 laser, and here you have got a bed. Now this is your bed. Okay, so what happens is, there is a roller over here and there is a roller over here, and on top of this roller there is this plastic sheet. This plastic sheet or foil, as we are calling it right now. So this is winding. This one is winding. So what will happen to this? This will unwind. Okay. So as this starts to wind, this sheet will start to move over here. Okay. On top of here, we have got what we call as a hot roller. We have got a hot roller. Okay. So what happens is, this sheet, this plastic sheet, is actually going to move in this direction. As it moves in this direction, it comes to a stop at a certain distance. Okay. That distance is defined by the bed which is underneath this plate. इस प्लेटफॉर्म के नीचे एक प्लेट होती है जो हमारा एक्चुअल बेड है, जो जिसको हम कहते हैं मशीन बेड. इस बेड की डायमेंशन के हिसाब से ये शीट आगे मूव करती है. ठीक है. जब ये शीट, फ्रेश शीट इसके ऊपर आ गई, उसके बाद क्या होगा, ये जो रोलर है, ये रोलर इस तरह से पहले इधर जाएगा और फिर इस एंड पे जाने के बाद वो वापस इधर आएगा. तो अब क्या होगा, ये रोलर अपने दोनों एक्सिस पे घूमेगा. ये हॉट रोलर है, ठीक है, हीटेड रोलर. तो ये क्या होगा, जो शीट है वो गर्म होके अपनी प्रीवियस जो नीचे की लेयर है उससे चिपक जाएगी. अब लेजर का काम इज बेसिकली, द वर्क ऑफ लेजर इज द कटर. ठीक है. सो व्हाट लेजर विल डू इज, इट विल कम एंड इट विल कट द शेप. It will only cut the shape. Once the shape has been cut, this hot roller will again move to and fro for one more time. So what happens is, now this shape will actually get stuck to the layers underneath, while this counter rotating rollers will again move and move the sheet forward. तो यहाँ पर लेजर का जो मैकेनिज्म है, the laser is actually not working for joining the process. It is actually working to cut the topography of that individual contour. Am I clear?
Yes.
अच्छा, अब आते हैं तीसरे पे. तीसरा है पाउडर. पाउडर की कहानी सबसे यूनिक है. पाउडर की कहानी, why it is, I am calling it as a unique, for the simple reason that over here you have got two powder, you have got a powder, ठीक है, lying on top of each other. ठीक. Now you bring in heat. How are you bringing in heat? You can understand the word laser. ठीक है. So laser is going to act as a heating source. अब when the heat is brought onto here, this is one particle and this is another particle. So what will happen is, at this point, at this junction, the binding will happen and the component will become something like this. ठीक है. So localized binding will take place. So when the heat moves through, not only this particle is getting deformed, but also this particle, and heat also penetrates inside. So the third particle, which is over here, it also gets some heat through the system, and as a result, what happens is these three particles may bind together. ठीक है. And the structure of the binded particle will be something like this. So which basically shows that a complete homogeneous bonding has taken place. So this is how powder particles work. Okay, so wire is completely in wire, the raw material is a thread. Over here, it is a sheet, and over here, it is simple powder. So these are the major systems which are commonly used in additive manufacturing in day-to-day applications. Then let us come to the second system, which is the liquid system. Now here, the concept is pretty much simple and similar to what you have got with respect to powder system. The concept is almost similar. The only difference is that instead of powder, what you are using is a liquid resin, okay, which is photocurable. That is the only difference that you have got over here. So what happens is over here there is a vat. हम इसको कहते हैं vat. Vat का इसका दूसरा नाम container भी हो सकता है, but we call it as a vat. Now underneath this vat over here there is this system which is called as the platform. There is this system which is a platform. ये तो आपको मैं साइड व्यू दिखा रहा हूं, इसका जो टॉप व्यू वो होगा वो कुछ ऐसा होगा. Means the surface is perforated. The surface of the platform is actually perforated. ठीक है. अब यहां से we pour liquid resin. And at the start of the process, the liquid resin is completely filled up over here, and this platform is actually over here. The platform is actually over here. Okay? And the liquid resin is filled up right up till here. Now what happens is this platform, it will move down. It will move down. By what distance? Now that's the basic question. If it is moving down, then the question is what distance? Any guesses?
So what will be the height of the?
No. One layer thickness. So the platform always moves down by one layer thickness. Now when this platform moves down by one layer thickness, due to this perforated sheets, what happens is liquid comes on top. Okay? The liquid is going to come on top. Now over here you have got a device we call as recoater. So this recoater is pretty much similar to what you saw with respect to the foil, the hot roller. Okay? Here the purpose of recoater is to move from this end to this end, thereby depositing a uniform layer of the resin on top of the bed. And then what happens? The laser. अब यहाँ पे laser जो है, it can be a UV laser, or it can be a CO2 laser, or it can be an argon laser. Any laser can work. CO2 laser definitely low wattage, करीब 5 watt से लेके 20 watt तक ही हम यूज करते हैं. ठीक है. UV laser generally 900 watt तक की चलती है, and argon laser is also somewhere in between 450 to 550 watts. तो हम इनमें से कोई भी लेजर को यूज कर सकते हैं. And this light, when it is emitted over here, what it throws onto the surface is a photon. And that photon, when it collides with the liquid molecule, it transmits its energy into liquid molecule and excites it, thereby releasing more energy into the system. And that is how the whole system starts to get heated up. Now the point is, where do you want the photon to strike? Okay? So if this is the bed and this is the contour geometry that you want to make, then you want the photons to strike over here. That is what the laser scanning path or part deposition path was in the process methodology, if you remember. Okay? This is defined by the software while understanding what the contour geometry of each layer is going to be. So that is how the whole system basically works with respect to liquid, solid, and resin. Any doubts with respect to this slide? Or any questions or clarifications you think you need?
Table can move in how many axes?
Table is not going to move in any axis. The table is going to remain static. This is the VAT. This table can only move up and down. That is the Z axis at max. There are many systems where the table actually never moves. The head, okay? This is called as the head. This, sorry, not head. This head actually moves up and down. So there are different systems, okay? Like in FDM, that is fuse deposition modeling. This system, it is the head that moves up and down. Okay. But in ballistic particle manufacture, again the head moves up and down. Okay. In selective laser sintering, it is the opposite. It is the bed that moves up and down. So there are different type of systems that work. The X and Y axis is controlled by the deposition mechanism, that is either the laser or whatever the source of heat that you are transmitting. The Z axis is controlled in a different way in different technologies. So by default, the machine is having 3 axes. Okay? By default, the machine is having 3 axes, but indirectly it will be 3. Directly, it would be generally 1 axis only.
So, but then how we will make a circular contour if we move in only one direction?
That you will understand when I'll start showing you the lab components. What happens is the machine head actually moves around this bed. This is your X and this is your Y. The Z axis is governed by the height. This is responsible for the height of the part, and the height of the part is related to your layer thickness. So there are different parameters that you will be learning as you go on learning this course. I have not started the lab component because you don't have the CAD models. So next class, when you come up with a CAD model, I'll start to show you how the system actually works in lab. Okay? You will be understanding, seeing the processes, and by the time you come to the lab, you will be actually fabricating those parts by your own self also. So let me go to the next slide. Now, next slide, basically, as I said earlier also, I have tried to differentiate with respect to materials, the work material, and also with respect to the energy resources that generally people use. So when you talk of energy resources, there are 5 broad ways of developing the system. The second, this is again something that was actually developed at a lab scale but never commercialized, because there is a process called electrical discharge machining, which also works on the same principle of voltage and current. That's why electrosetting was not very successful. So this was not really commercialized, but all the other systems have some sort of what I would say components which were actually commercialized. So that's why I have broken it into basically 6 components, but the majority is 5. The first one is solidification of resin by electromagnetic radiation. Now, that is what I explained to you in the previous slide also, that a photon is released and that photon actually strikes the liquid resin and creates, as a result, what happened is photopolymerization. So the whole process of photopolymerization is actually electromagnetic radiation, which is emitted by a source. So the most common system that you will find over there is stereolithography. And another process is called as solid ground curing, SGC. Solid ground curing is something which is very commonly used by jewelers actually, who make multiple designs of jewelry at the same time. So solid ground curing is something which is also very common system. Here we use a UV lamp, but in stereolithography we use a UV laser. Okay. There are other processes also, that is beam interference solidification. Now in beam interference solidification, what happens is there is one laser coming from top and the another laser is coming from side, and the line at which they intersect is where the polymerization actually takes place. But this process has a deficiency because this laser is coming onto the work surface unobstructed, whereas this laser, the second laser, the laser 2 and laser 1, the laser 2 actually is obstructed by the side of the boundary wall. So the intensity of 2 lasers is not similar. That's why this process was not very successful. but still I'll give you a brief introduction about that when I describe the processes to you. Now, the second is solidification by electrosetting fluid. Now, in electrosetting fluid, basically what we have is we have a vat and there is a fluid inside this vat, and this fluid is actually containing some salts and metals. Salts and metals. Okay? And these salts and metals are actually going to be exposed to current as well as a voltage, a small amount of voltage. As a result, what will happen is it will cause electrolysis over here, and due to electrolysis, there will be two electrodes over here. So one of the electrodes will start to accumulate the material out of this liquid, and second one will become a bare electrode. As a result, you will get an object as per the design. By varying the current and voltage, you can get required deposition at the required spot. But this process is very complicated because you need to control the voltage and current at the same time, thereby making the deposition at the desired position. So this process is not very simple, and that is one of the reasons why this process was not commercialized also. Then comes a very simple process that is called melting and solidification of the particle. Now, melting and solidification is something very simple. You have a wire. The wire is being fed into a heater. Okay? There is the heater mechanism. The wire goes through this heater mechanism, comes out as a semi-solid or solidus. That is what we generally call it. It gets deposited on the work surface and it cools. And comes back to solid phase. So melting and solidification of the part material is again something which is the easiest mechanism that has been thought of. And this is the mechanism which actually is primarily utilized nowadays in most of the additive manufacturing systems. This is the mechanism which is generally utilized. Then we have got another process which is called fusion of particles by laser. So here the heating mechanism is going to be developed with the help of laser. So what is going to happen is there are some powders which are lying around, and the laser will come and heat this, transfer the heat into the layers. Okay, so what will happen is these powder particles which are there will start to get will start to bind together and form a solid object. So you will have something like this. You will have some structure like this. So these three particles will actually become something like this. So now you can understand that there is a bonding between these three powder layers. So the most common over here is selective laser sintering and lens, laser engineered net shaping. Now lens basically uses metallic powders. It uses metallic powders. Okay? Whereas selective laser sintering uses polymeric powders. However, there is a new version of SLS that is called as SLM, selective laser melting. Selective laser melting also uses metallic powders as the raw material. So fusion of particles by laser, that is how it happens. Then fusion of particles with the help of a binder. Now this is something which is very simple, but the problem with this type of a system is it is not going to give you a product which is going to be very sturdy or handy. It is not going to give you a product like that. What happens is there is a bed and there are powder over it. There is a head which is coming and it is spraying some binder, liquid binder material. And this liquid binder is actually nothing but a sort of a glue which is poured over the powder material, and those wherever the glue falls, the material stick together and rest of the powder material remains as a loose powder. It doesn't get attached to anybody. So that is how this thing works. And then processes involving solid sheets and laser, I believe you have understood. The same process where I explained the foiling process. So here what is going to happen is you will have a heat based, this is a heated roller. So the work of heated roller is to bind this sheet to the previous layer, and the laser is basically going to be acting as a cutter. And it will basically cut the sheet according to required dimension. So what is happening is laser is actually giving you the XY axis. The laser is actually giving you the XY axis. the heater, when it pushes the sheet downwards, is giving you the z-axis. Any doubts? Any doubts over here?
No, sir.
Okay. Then this is all I wanted to discuss today. Thank you.